Hi, College Algebra, and today we're going to do 6.2, still two variable linear systems, but today we're going to focus more on the elimination method. So the elimination method is when you get coefficients of either variable the same but opposite. Sometimes you have to multiply by a constant. So for example, if I have 2x plus 3y equals 7, and negative 2x plus 3y equals 12. Here we have a positive 2x and a negative 2x that are equal and opposite. Therefore, I can then add the equations together, and 2x minus 2x would cancel out and eliminate, giving me, 6y equals, 19. And then from there, I could just solve. And then after I get a y value, I can replace it into one of the original equations. So here, I see that I have y's that are equal and opposite, so I'm just going to add the equations together. 3x plus 5x is 8x, y's cancel, 4 plus 12 is 16. We can divide by 8, we get x equals 2. By taking that, I can plug it back into my original. So I get 3 times 2 plus 2y equals 4. 3 times 2 is 6. Subtract the 6 from both sides. 2y equals negative 2. Divide by 2. Y equals negative 1. So I get the coordinate to negative 1. Here, I don't have easily accessible opposites, but again, I can always multiply one of the equations by a constant. So I'm going to multiply the second equation by 4. This way, I'm going to get positive 4y because I get 20x plus 4y equals negative 4. And my first equation did not change. 2x minus 4y equals negative 7. I can combine my equations. 2x plus 20x is 22x. Y's cancel. I get negative 11. Divide by 22, divide by 22. We get x is negative 1 half. Plug that into one of my original equations. I get 2 times negative 1 half minus 4y equals negative 7. 2 times negative a half is negative 1, so we can add that 1 over. So we get negative 4y equals, well, negative 7 plus 1 would be negative 6. Divide negative 4, divide negative 4, we get y is 1.5. Or if you prefer, 3 halves. So I get negative 1 half and 3 halves. Here, again, elimination, but I don't even have one that I can multiply once. In this case, you can multiply both equations to cancel something out. So you'd pick one of the variables for the sake of argument. I'm going to pick y again because I already have one that's negative. So if I multiply this top one by 4 and this bottom one by 3, I can get both these y's to go to the same number, in this case, 12. So 5x times 4 is 20x. 3y times 4 is 12y. 9 times 4 is 36. 2x times 3 is 6x. Negative 4y times 3 is negative 12y. And 14 times 3 is 42, I believe. Just double check that. Yeah. From there, we can combine. We get 26x, y's cancel, equals 78. Divide by 26, divide by 26, we get x equals 3. Take that 3, plug it in for x. We have 5 times 3 plus 3y equals 9. So I can subtract that 15 from both sides. So we get 3y equals negative 6. Divide by 3, divide by 3. y equals negative 2. So when we graph uh, in two equations, remember, first of all, you got to get y by itself. Well, earlier with the last lesson, we talked about having infinitely many solutions or no solution as well. Well, if they're two lines and they intersect, they have to have one solution, which makes sense. The solution is the intersection. If they have two lines directly on top of each other, they have infinitely many solutions because every single place they touch is a solution and they touch literally everywhere. And if they're parallel, they never intersect, so therefore they'd have no solution. So if I'm given these three possibilities, let's solve these, and we can actually just look at the graph and tell which one's which by matching that way. So for example, if I multiply this top one by 2, we would get positive 4x minus 6y equals 6. I can then go to combine them because my x's are going to cancel and my y's are going to cancel. So what am I left with on the left-hand side? I have nothing. So I'd have 0. So 0 equals 12. Well, that is a false statement. So this has to be a no solution. Well, graphically, a no solution are two parallel lines. So A has to go right there. I'm going to jump to the letter C because I think it's easier. For example, I'm seeing that I could directly multiply by 2, giving us positive 4x minus 6y equals positive 6. Combine 0, 0. Well, that also gets down to 0. That is a true statement. So that would be infinitely many solutions. So I should only see one graph. And that's what happens in this first one. So I'd say that's letter C, which means this one has to be letter B, but let's solve it anyway. Because there is an intersection, I know there is only one solution. So, looking at these two equations, I think the easiest way is to multiply this bottom one by negative 2 to cancel out the x's. So I get x times negative 2 is negative 2x. 2y times negative 2 is negative 4y. And 10 times negative 2 is negative 10. I can combine like terms. X's cancel. I end up with negative 7y equals negative 7. So y equals 1. Plug that back into one of the originals. I'm going to say the first one. We get 2x minus 3 times 1 equals 3. Negative 3 times 1 is negative 3. So I get 2x minus 3 equals 3. Plus 3 plus 3. 2x equals 6, divided by 2, divided by 2, x equals 3. So I get the coordinate 3, 1, which, if I am looking over at my graph, that's exactly where they're intersecting right there at the coordinate 3, 1. Here, so if I were to multiply this top one by 2, we get 2x minus 4y equals 6. Combine. X's cancel, y cancel. 0 equals 7. No solution. Here I can multiply this one by negative 2. Negative 4x plus 2y equals negative 2. Combine. 0 equals 0. Infinitely many solutions. And then a common equation is distance equals rate times time. It's a common physics equation, which should make sense. For example, if I'm going 30 miles an hour for 2 hours, 30 times 2 would tell me that I traveled a total of 60 miles. So, an airplane is flying into a headwind, traveling 2,000-mile distance between the two cities in 4 hours and 24 minutes. On the return flight, the airplane travels distance in 4 hours. Find the airspeed of the plane and the speed of the wind, assuming both remain constant throughout the trip. So, I should know that no matter what, both of them are traveling 2,000 miles. So, both equations should end in 2,000. Now, what else am I given? Well, I'm given the time in both. So I know that one is going to be times 4, and the one's going to be times 4 hours and 24 minutes. Well, because I have this 24 minutes component, it's kind of harder to interact with it. I don't want to write 4 hours and 24 minutes in an equation. So what I can do is I can do 24 divide by 60 because there's 60 minutes in an hour. And that would tell me that that is actually zero point 0.4 of an hour. So this whole thing turns into 4.4 hours that I'm being multiplied by. So that's the rate, or that's the time. All I need to figure out is the rate or the speed. Rate's also considered speed. Now I'm flying into the headwind. So there's wind going on, and wind has its own speed. I'm going to have plane be P and wind be speed of W. Well, if the airplane is flying into the wind is causing friction pushing back on the plane, effectively slowing it down. So what's actually happening is we get the plane speed minus the wind speed times that 4.4 hours. And on the way back, that wind is pushing the plane, propelling it forward. So the plane speed is actually being added by the wind speed. From here, you have a couple choices. You could distribute the 4.4 and the 4, getting all sorts of interesting coefficients. But conceptually, we're just trying to get the P and W by themselves. So I'm just going to divide right now. So we get 2,000 divided by 4.4 gives us that. So I get P minus W equals 454.54 repeating, and P plus W equals 500. Well, from there, it's just systems of equations. So I can just add the equations together because my W's are going to cancel. So I get 2P equals 954.54 repeating. So I can just divide by 2. Plus 500 divided by 2. So we get a plane speed of 477.27. And if I know that, I could do 500 minus that speed. And the wind speed has to be 22.72. 22.72, sorry. Thank you for listening, and I hope you have a great day.